Good evening, everyone, and welcome to our webinar. I'm Graham Hunt, convener of the Renew Sydney Central Branch. Welcome to you all, even if you are signing in locally from the Sydney region or elsewhere in Australia, or possibly from overseas. It's always exciting to be engaged with so many people through this medium. Firstly, I want to engage the traditional owners of the land upon which the Sydney Central Branch operates, and from where I am at the moment. And that is the Cadigal clan of the Eora Nation. We acknowledge their leaders, past, present, and emerging, and we also acknowledge their sustainable stewardship of the country over many millennia. I would also like to acknowledge the traditional leaders of other parts of the country or in other lands, wherever you may be joining us from. Tonight, we have the pleasure of welcoming three speakers who will help you learn more about growing our own food. Firstly, Nick Ritar from Milkwood, who will introduce us into the incredible kingdom of fungi. And then we'll have Gert Hendricks and Luke Barbuto from Farmwall, who will educate us about small-scale, closed-loop food systems ideal for urban environments. If we're not able to answer your questions tonight, hopefully we can do that with a follow-up email. Firstly, I would like to introduce Nick Ritar, who is director and co-founder of Milkwood and a permaculture educator. I've been aware of permaculture for quite a while, so it would be good to know more about them and what they do. They are dedicated to teaching and sharing permaculture skills and have been doing so since 2007 through a broad range of courses and providing information from their website. They are just about to launch their online mushroom growing course, and so Nick is here to tell us all about it. So over to you, Nick.
Hi, Graham. Thank you for inviting me along tonight to talk to everybody. Great to see people coming in from all over Australia and other places in the world as well. I just want to acknowledge that all you guys down there or up there on the North Island, stuck in lockdown, and you know, our hearts go out to you all, and know what a challenging time it is for you, and just want to wish everyone well and hope everyone stays safe. Tonight I'm going to be running you through a whole bunch of stuff about home mushroom cultivation. So I think I'll go ahead and share my screen with you if that's good. There you go. Okay. So hopefully everyone can see that presentation there. I'm coming to you from Milkwood country down here in Tulloon, which is otherwise known as Cygnet in southern Tasmania. We also just want to acknowledge the traditional owners of the country throughout Australia and recognising their continuing connection to land, water and community. This area around here, it's called Cygnet because it's famous for the swans that live in the bay here and on the flats around the town. And this was an incredibly important hunting and gathering ground for Aboriginal people and for 40,000 years. And we're lucky enough to call a little bit of it home now. So Milkwood was started by myself and my partner Kirsten nearly 15 years ago now, and it's been an amazing journey. We've had tens of thousands of students do different face-to-face courses with us over the years, all centered around the ideas of permaculture, which is really around living in ways that don't just aren't just about not damaging the planet. They're not just sustainable in the sense that they don't damage the planet. We're looking for ways that actually enhance the ecosystems around us and make them more productive for ourselves, for the natural world, for everyone. So mushroom cultivation has been sort of part of that journey for us for nearly 10 years. And we've been teaching it for a little less than that. Once we got our skills up a little bit, we started teaching people, and we started bringing people to Australia to teach us how to do mushroom cultivation better. Fungi are amazing. They're just so diverse and so many different ways that they can be used in permaculture systems and in our lives. To put it into perspective, there's about 375,000 species of plants, but the best guess is that there are around 3 million species of fungi. Only about 120,000 of those species have actually been classified. So only about 3% of the species of fungi that are out there have actually got a name. So if you want to get famous and name some sort of organism after yourself, go out and start exploring and studying fungi, because there's plenty left to be named. And even though we've been excited by them for hundreds of years, thousands of years, even tens of thousands actually, we don't actually know that much about them yet. They're kind of secretive. They live underground. They live inside logs in places that we can't really see. They pop up seemingly randomly. And some of them, give you visions, and some of them might even kill you if you choose the wrong ones. But given that there are that many different species, there's only actually a few that are deadly, and maybe a few hundred which are poisonous. So there's not as bad as plants in terms of your miss rate, if you like. There are plenty of very, very toxic plants. So just like plants, you wouldn't go out and eat something that you didn't know what it was. Same deal with fungi. You never eat something unless you know exactly what it was. We enjoy foraging. Those skills take a little bit of time to learn. I've got this little diagram here that is from our book, and it shows something around the life cycle of fungi. One of the things that people, don't necessarily recognize is that most of the life of a fruiting mushroom is not spent in this mushroom shape. It's mostly as mycelium. So the mushrooms are just the fruiting body, and they're there purely to spread the spores. And the spores spread sometimes a long way, sometimes not very far at all, and until they fall onto some kind of medium, whether it be soil or a leaf or a log, which supports their growth. And then they germinate, which is kind of weird. They're not like a seed, because they're actually more like sperm or eggs. They only have half of the genome of the fungi in each of the spores. But when they land, they start growing, even though they've only got half of that DNA that's required for them to complete their life cycle. They start growing, and some of them can even live for hundreds of years with only half of the genome, growing into masses of mycelium just as half an organism. But when they do eventually meet a compatible mate of the same species, they mate and they share their genetic material, and they grow into more and more mycelium with this shared genetic code. And that then allows them to form pins, which develop into mushrooms. Eventually they mature, and the cycle starts over and over again. These spores are really the way that fungi travel, and they travel everywhere. They've been found in every ecosystem on the planet, in the oceans, in the Arctic, in the Antarctic, in the driest deserts. There are fungi everywhere. They're inside you, they're on your skin. If you take a breath, an average human breath has about 3,000 fungal spores in it. But don't worry, you're very, very good at dealing with them, and most of the time they don't cause you any problems at all. It's only when you're allergic to them that they can cause a few problems for some people. So one thing that people also often don't recognize is that these mushrooms, these beautiful edible, in this case, king oyster mushrooms, Pleurotus orangi, they're made out of the same material as that mycelium, which is growing through the forest floor or through a log or through leaves. There's no real difference. And that mycelium is made of proteins, which are much more similar to what we're made of than what plants are made of. They're predominantly made of a protein called chitin, which is almost identical to the material which makes up the shells of prawns and the exoskeletons of crustaceans. So they're very similar to animal protein. And in actual fact, we share a common ancestor that we don't share with plants. We are, in a sense, descended from fungi and closer related to them than we are to the world of plants. And in the same way, similarly, we can't get our food from light, and neither can fungi. They're not like plants. Plants convert carbon dioxide in the atmosphere into the sugars and the carbohydrates that they need to survive and grow. Fungi can't do that, and we can't do that. Fungi, like us, have to digest preformed organic compounds, which they find out in the environment. And that's their superpower, really. They can create all kinds of different amazing chemicals from preformed organic compounds in the environment. And they could be, like I said before, leaves, a log, sometimes soil, sometimes animals. The tinea growing between some of your toes is a fungi which is digesting the preformed organic compounds of you. Some of them live in symbiosis with plants, trading sugars in return for minerals that they find in the environment, and other ones are parasitic on plants and on animals. So there's lots of different life cycles that they live by. The ones that we're generally interested in are the ones we call saprobes, that live by breaking down the organic matter in preformed plants, and usually from plants, logs and sawdust and the like. Mostly we like to eat them. So, they're incredibly healthful, they're incredibly yummy, and I'm sure a few of you want to learn how to grow some of them. But before I get into that, I just want to make a note. Part of the reason why we teach this is because the way mushrooms are grown commercially uses a lot of plastic. Plastic bags. And many of the times you'll learn how to grow mushroom cultivation, grow mushrooms, the techniques rely on using those kind of plastic bags. So the techniques we teach are all about reusing materials, either upcycling plastic buckets and glass jars and the like, or using natural materials which the fungi can actually eat and break down. So this is a basic overview of the 4 different methods we use to grow mushrooms at home. These stages here require sterile conditions to produce the grain spawn or sawdust spawn. So often for beginners, we'll end up purchasing this from a supplier. It's quite cheap, and there's some really good suppliers in Australia. And that allows us to then go from this grain spawn, which is the mycelium growing on grain, to one of these other techniques, either wooden dowels for inoculating logs, or grain or dowels to make garden beds, or grain spawn to go into pasteurized straw or sawdust in buckets. Or we can use sterilized straw or sawdust or enriched sawdust to grow just about any species of saprobic mushroom. This technique is more advanced. It's these 3 techniques that I'll quickly talk about tonight. And again, this is a diagram from our book. Commercial mushrooms, here's the difference between them. This is a commercial enokitake that many of you, or enoki mushroom that many of you are probably familiar with. This is the way they grow when they're homegrown. These are starved of oxygen and grown in low light conditions. These ones are grown in full light, and they're a beautiful golden colour. In actual fact, their Latin name, Flammulina velotypes, means the velvet-stemmed flame mushroom. They have this dark stem and these beautiful orange caps, and they're incredibly nutty and flavorful. So we can grow these kind of ones, but that's an advanced technique. Mostly we're going to use these techniques at home. They're the easy introductory methods. One of my favorite techniques is this. If you've got a little bit of space outside, a wood chip bed, garden bed, and growing the garden giants or wood bluets or even shaggy manes. These are the garden giants, aptly named because of their size. This is Brenna Quinlan, our illustrator, holding up one beautiful big garden giant mushroom. Here's Kirsten making up a batch of what we would call wood chip spawn in this big tub. And this is the first stage we often do. We make up a batch of fermented wood chip just in a barrel. and then put it in this tub and inoculate it with the grain spawn of the King Stratheri. And a few months later, they start popping up like this, and each day they just get bigger and bigger and bigger until they're huge like that. And then you've got a massive meal of them. We often then transplant that mycelium into the garden under a tree and get a second harvest. And they really are an amazing mushroom to eat. Very, very tasty and huge. Even better when they're harvested young and small, and they're firmer and fantastic. So that's growing in garden beds. Another technique that we really like to do is this log growing technique, or log growing technique, particularly with shiitake mushrooms. Here's my little boy, Asher, picking some fresh shiitakes off eucalypt logs. It's an incredibly productive technique if you've got the space, but it does take a little bit more time. Here's some more shiitakes growing on an oak log, and this is the basic process. We drill those logs, we harvest them from live trees, we drill them and then inoculate them with these wooden dowels that are already have the mycelium growing on them. Once that banged in, we leave them for a few months, and then but usually minimum 6 months, somewhere between 6 to 18 months, depending on the time of year that you inoculate them, and out pop gorgeous shiitake mushrooms. They're pretty easy to grow as long as you choose the right species of logs to go, right species of tree to harvest, and you inoculate them at the right time of year, and you keep them in the right way. But it's not rocket science. And you can get an amazing harvest, and it's a way to utilize the photosynthetic capability of the forest without destroying the forest through thinning and maintenance of a woodlot. Finally, the technique that we probably grow the most mushrooms with is this pasteurized straw and sawdust technique in a bucket. So we get recycled food grade buckets from cafes, and we drill them, and we then pasteurize straw and sawdust just in hot water for about an hour at between 60 to 80 degrees Celsius. We drain that really well, and then in cleanish conditions, we mix in the grain spawn and then pack it into buckets. And within, with pink oyster mushrooms, within a few weeks, you can get massive harvests of mushrooms off those buckets. It's a really productive way of doing it. So here we are mixing grain spawn in with that pasteurized straw sawdust mix, and then packing it into the buckets once it's all, before we don't mix the spawn, the grain spawn, in until it's cooled down. We pack it into buckets, and in a few weeks' time, this is the kind of thing that you get. Now, we enhance the growth and create a perfect fruiting environment, again, trying to use recycled materials as much as possible. So this is a diagram of a mushroom fruiting chamber that we made out of just recycled shower screens and supermarket shelves and some old dishwasher racks. And we add a humidifier into there to increase the humidity, but this was just out on our veranda with no temperature control, anything like that. And that produced hundreds and hundreds of kilos of mushrooms for us, for our family, for years and years. We've since moved on from that location. Now we're actually using a shower cubicle in an unused bathroom to grow, golden oysters like these ones and pink oysters. So this is actually the shower cubicle here in the building that I'm at now, just upstairs. And we don't need that bathroom, so we don't need that shower cubicle. So we're using it to grow all kinds of mushrooms. There really is a huge array of different species that you can grow with the different techniques. Some of them are more advanced, some of them are more easy, but it doesn't take that long to learn how to grow them. And we actually have a free guide available on our website that I think Graham's going to put a link that you can click up a little bit later. It's a free guide, and we've always taken the attitude that we'll give away a lot of our stuff for free, almost all of our information for free. But sometimes it's nice to actually be led through a course where we can answer all your questions directly and provide you more detail. So go ahead and download that free guide. And if you're interested, we are starting our mushroom course in just a few days' time, actually. It's on sale at the moment. We only do it 4 times a year, so the next one won't be until summertime. Yeah, I'm happy to answer any questions at all. The other thing you can do, there is a big chapter in our book about that, so you can get that from most libraries as well. There's 1/5 of that book is all about mushroom cultivation, so you're welcome to get more information there. Yeah.
That's great. Thanks, Nick. We have a question. If people can place their questions into the Q&A box rather than the chat box, would be appreciated. Then it's easier for us to keep track of them. But there's plenty of space for questions. So if people want to start typing in their questions, we can put them to Nick. We do have one question from Felicity. She's wanting to know if you can provide more information, read the humidifier you used, approximate cost, I guess, and details.
Yeah, so there's a range of different humidifiers that you can buy off the shelf. We don't recommend using the little tiny ones that people often have in their kids' bedroom when they have a cold or something. They typically use heat, and that's an inefficient way to create humidity. You can get a really good cool mist ultrasonic humidifier for about $50 that hold about 6 litres of water, and that'll keep you going for a couple of days in your mushroom chamber before having to refill it. Or you can create more complicated humidity buckets and the like for maybe $150, $200. That's the main piece of equipment that you need to really consistently get a good harvest. Increasing humidity up to almost a cloud is the best way to ensure that your mushrooms fruit really, really well. Temperature control isn't as important as a lot of people stress. It's not that expensive to do that humidity control.
I was wondering about light. The shower cubicle you showed was in a bathroom with, it looked like it was quite light with windows. Is that an impact? You need to draw blinds or keep it dark?
No, so that's actually another kind of one of the many sort of things about mushrooms that is common knowledge, which isn't necessarily that true. Most of them actually respond very well to light and like quite bright conditions. So we actually add artificial lighting to increase the intensity of the colour and produce a better texture of our mushrooms. So as long as they don't have direct sunlight because of the heat is a problem and because of the drying nature of direct sunlight. But otherwise, we just have them on a similar day-night cycle. They need night time as well, but typically 12 hours of light, 12 hours of dark once they start fruiting.
Well, the questions are starting to come in now. We have one from Christy. She's wanting to know, how do you deal with gnats getting into the substrate?
Yeah, so fungus gnats can be a bit of a challenge, mostly by keeping the entire area clean. We do use those little yellow sticky traps sometimes, but the fungus gnats don't do that much damage. It's a bit like vegetable gardening. If your mycelium is growing very strongly and it's flourishing, then a few insect pests aren't a big deal. It's only when it's weak and failing that they sort of take over. So they're usually a good indicator to get rid of that batch and grow more. So it's pretty much about getting into the habit of things. We find that the more that you inoculate and the more regularly you do that, the better your yields come.
We have a question from Lee saying, thanks, Nick. I've inoculated some logs with shiitake maybe 10 months ago. No fruit yet. Do I need to keep the logs moist? They are in a shaded, sheltered spot.
Okay, so it depends very much where Lee is. 10 months ago, that would have put them, so assuming they're in Australia, 10 months ago would have put them at sort of October last year when they were inoculated. That means that they were being inoculated just coming into summer. Now, if they're in a hot, dry place and they didn't protect those logs from the direct sun, those logs could have dried out. But listen, you will often not get a yield until 18 months after you inoculate a shiitake log. So I would be expecting Lee might get a yield this spring, or it could be not until next autumn. The way to test is to look for spongy sections of the log and to see white mycelium growing at the end grain of the log. If that's happening, they can soak the log overnight and then give it a good whack with a rubber mallet, or even throwing it up there and dropping it onto concrete to kind of scare it a little bit. And that's a good way to sort of encourage them to fruit.
Okay, we have a question from Sean. Do you find you need to dial in CO2 levels for many gourmet or medicinal varieties?
No, not really. We manipulate the fresh air levels in our fruiting chamber just using computer fans on timers, just a little 12-volt timer. And what that does is it flushes out the carbon dioxide out of the fruiting chamber and replaces it with fresh air. We do that about 5 times an hour, depending on the species. And it's just about keeping that fresh air up. We don't ever actually monitor the CO2 levels. You can do that. It's just that because it's only recently that CO2 monitors have become reasonably priced enough to do it, mushroom cultivators developed really good techniques by flushing the CO2 out and using fresh air. The CO2 levels of, if you want to try and grow something like those paper white straw like inokitake, then you do need to reduce that fresh air exchange to try to do that. But most people are actually going for the reverse. They're trying to get more oxygen in there and less carbon dioxide.
Okay, good. We have another question. Have you just cultivated mushrooms for eating, or have you also experimented with mycelium materials?
So we've mostly, we've mostly grown mushrooms for eating and for medicinal mushrooms as well. We grow turkey tails and reishi and things like that to make tinctures and teas out of. We've done a few experiments with mycelial materials, including layering cotton waste with reishi, Ganoderma variety, mycelium, and having it grow through it to experiment with leathers and the like. There are people who specialise in that kind of stuff, and it's not our specialty. So we've only really played with it a little bit, not experts in that kind of thing yet.
David's keen to know, can you plant mushrooms for that so that you harvest a continuing crop rather than a single clut?
Yeah, so different. So with the bucket culture method, we'll typically get 3 or 4 flushes of mushrooms from each bucket over. They'll flush for a week, and then they'll have a few weeks off, and then another flush and a few weeks off. So you do get a continuous harvest for a period. Then, in theory, you could use the mycelial material to inoculate more buckets, but typically that process ends up adding more contamination and reducing the nutrient content because the initial lot has got grain in it. That grain is an important nutrient for the growth of the mushrooms. So that's using the bucket method. With the log method, those logs will keep flushing for up to 5 years. And with a garden bed method, it's easy to pick up chunks of mycelium and distribute them around the garden to new locations and bury them in new wood chips and get them all going again. Yeah.
Okay. Gab would like to know, where would you purchase the spores to start the process?
Okay, so one thing that I didn't make clear in the presentation is, although in the wild mushrooms often breed using spores and grow using spores, the actual most common method that they use in nature to spread is tissue culture or cloning, where a small part of the mycelium breaks off and is spread to a new location. You can imagine a tree that's infested with a mycelium falling and a log landing in the water, being swept downstream where it finds a whole bunch of other logs, and the whole lot continues growing through that mass of suitable substrate material. So the same way with mushroom cultivation, typically to ensure we've got a good strong chunk of mycelium to start with, we don't start with spores, we start with spawn, S-P-A-W-N, and that's mycelium growing on some kind of substrate which is easy to distribute, typically grain or sometimes wooden dowels or sometimes sawdust. So where do you purchase that grain spawn from? There's a bunch of different suppliers all over the world online. If you search online, I don't think Renew appreciates me promoting particular brands, but there are some great Australian mushroom suppliers who sell spawn. Yeah, I'm getting mixed up now. To start the process off with, we don't sell anything like that. We just do knowledge.
That's great, Nick. Look, there's quite a few questions still there, but we might leave them for the moment. Maybe you might have a go at answering them in the background, but I think it'd be good to move on. And so I'd like to introduce our next speaker, who is Gerd Hendricks, who will give us a brief introduction to Farmwall, who are an innovative social enterprise using agri-food and educational technology for the purpose of growing food in urban environments. They do this by providing a creative and interactive learning environment to increase understanding about healthy food and growing. So we'd like to hear more if you can let us know, Gert. Thank you.
Thanks, Graham. Thank you for the introduction. That's great, and thank you for having us on this amazing webinar. Yeah, just thank you to Nick as well. It was an amazing presentation. I grew oyster mushrooms myself for a whole year in a big shipping container, so it's a really rewarding and joyful experience. And they're an absolute delish with some cracked pepper and salt in the pan. I would say let's garnish them as well with a sprinkle of microgreens, and then dinner is sorted. So yeah, we're going to give it a go to present with two of us. So I'm going to give you guys a bit of an introduction on Farmwall and what a microgreen is, and then Luke Barbudo or Farmer Luke will talk us through how to grow the microgreens at home. So I'm going to start sharing my screen. Oh, there you get my notes. Little animation, bring the story. So yeah, Farmwall is located in Elphington, on the traditional lands of the Wurundjeri people of the Kulin Nation. They are the traditional owners of this land, and we pay our respect to their elders, past, present, and emerging. So today we're going to speak a bit about the mighty microgreens and yeah, why we think that microgreens are such an amazing addition to every home and every classroom. Yeah, myself will be presenting. I'm the founder and CEO at Farmwall, and then a bit later on we'll pass the puck to Luke, who is doing a lot of education and who's a facilitator at Farmwall on topics all across urban farming, growing food in the city. So at Farmwall, we are creating an educated and connected community of individuals who have learned how to grow food regeneratively and sustainably using technology, design, and natural principles, of which the outcomes benefiting their own health and well-being, that of the community, and that eventually of the planet. So our goal pretty much is to design tools and educational resources to educate people on how to grow microgreens and leafy greens in the city. So on the right side, you can see our flagship Farmwall. Farmwall is a vertical farm that operates on aquaponic principles, and we basically use fish in the process. The fish create a great environments and adds nitrates to the water quality, so that there's plenty of nutrition in the water for the microgreens and the leafy greens to grow into healthy leafy shoots. Yeah, and the Farmwall is a great representation of the natural ecosystem and how nature uses its design to basically grow plants. And in the Farmwall, we can grow a range of delicious and nutritious greens. So we've also developed systems for people at home, which we started doing when COVID started last year. And in Elphington, we've got the beginning of what's an urban farm, on which we're hoping to educate more in the future and develop more resources as well. So today is all about microgreens. And so what is a microgreen? The microgreen is basically the very early stage of a vegetable or edible plant at the first stage of its existence. So when a seed germinates, it turns into a sprout, and from a sprout it turns into a microgreen. So the microgreen has the first couple of leaves, which we call the seed leaves, or cotyledons. Took me a couple of times to learn how to pronounce it. But yeah, they're basically the very early beginning of a vegetable, and vegetables like we know them, like a broccoli or a radish. And often the microgreens are very cute, small, colorful, and very tasty as well. What we know about microgreens is that because they're at that very early stage, they're highly nutritious. And some people claim between 4 to 40 times even more nutrient dense than the larger counterparts. So they can add a lot of value to our lives from a nutritional perspective. They're also very easy to grow, they're fun, and it's a convenience thing. You can add them pretty much to every meal, breakfast, lunch, dinner, and it's so easily harvested and added to our meals. So yeah, a journey of 1,000 miles begins with a single step, and we see microgreens as one of those as one of those first steps. A step to start your journey into growing food at home, and a step to start your journey of learning more about growing food in a regenerative and sustainable way. So yeah, why do we think they're so mighty and that they bring so much value? Is we see them as a real gateway into our future, and a future of more regenerative farming, a future of more full spectrum agriculture, and a future where food is a much larger part of all of our lives, and especially the act of growing food. Growing microgreens at home doesn't only bring us nutrition and fresh produce that we've grown in our own households, but actually increases our well-being, because we're actually observing greens being grown. We're observing how they're growing. We're surrounded by nature, and it actually impacts our health and well-being, and it calms our nervous system, knowing that we've got food growing in our direct environment. Growing microgreens can be can be great satisfaction, because it's instant gratification. Within a week to 2 weeks, you'll be harvesting your first yields and getting that real feeling of accomplishment. Also, with children and people in general, it's microgreens are exciting. They bring inspiration. They're empowering, and they allow us to kind of start experimenting with horticulture and agriculture in a very micro setting, and in a micro way, without much to lose or much to win. So it's a way, if we all grow microgreens at home on a regular basis, it's a way to basically inspire people to start growing food at home and start being part of a more regenerative food system. And eventually that'll bring more benefits to us and to the planet. I'm going to pass it over to Luke, who will tell us a bit more about the varieties and how to grow them.
Cool. Thanks for that, G. Yeah, I'm coming from Sydney, Gadigal country. Farmwall has some operations there, mainly in Sydney and Melbourne. And I'm one of the urban farmers and education coordinators in Sydney as well. So yeah, I'm very much involved with the day-to-day sort of running of the seeding and the growing of microgreens. So G's alluded to it earlier. What are microgreens? It sort of sounds weird, but it's just the early stage of growth. And we're looking at really vegetables that we already know and love. So we've got coriander, we've got rocket, we've got pea shoots, amaranth, things like that. Radish is a really popular one too. So what we're trying to do here is just promote the first few stages of growth and then they're ready to be harvested generally within a couple of weeks. So I might go to the next slide, and I'll sort of talk you through it all. Let's see if, yeah, so this is an example of sort of some of the ways you can, I might better take over, G, actually. Let's have a look. And I can share my screen. And we should be golden. That should be working for everyone, I think. Yeah, so let's jump through. So this is some simple ways of doing the microgreens. So on the left, we've got snow peas. You can just have them as is, which is great. And they also work really well as garnishes too. So you see there, we got, different options there in salads or on top of meals, things like that. So we found last year during lockdown, a lot of our normal operations were basically shut down. We couldn't really go to the cafes and the venues where we were growing microgreens. So we found almost by accident that there was a really strong online community of people who wanted to learn how to grow food in their homes, in their workplaces, in their schools. And so that was something we found really encouraging. And from that, it's actually spawned kind of the next evolution of Farmwall, which is really great. And we've created an online community where people can come together, share their tips, share their wins and failures and things like that. So that's something we're really excited about. We'll go on to the actual, process of growing microgreens. And the good thing about microgreens is you can very easily grow them at home with not really much any little fancy technology or anything like that. So the first step is you need a growing medium. So things like coconut coir, which is basically a material just from coconut shells and husks. That's normally a waste material. You can use soil and potting mix. You can use hemp, which is what we use sort of commercially when we're growing lots of trays. And you can even use newspaper. Basically, it just needs to be able to soak up some moisture and maintain moisture so that the seeds can germinate. So newspaper, not many people buy them anymore, but anything like that, paper, newspaper, magazines, things like that. Then you got to choose your microgreen. So I generally recommend radish, broccoli, and mizuna. They're really easy to grow, and they generally have quite a successful germination rate. And they're also vegetables that people are sort of used to. So most people would know radish and broccoli. Mizuna is a Japanese mustard green, very similar to like rocket or chimichurri if you've ever had that. It's got that real nice sort of peppery mustard kind of flavor to it. I really like it for its color and also its flavor. So I've sort of thrown that one in there. But they're really easy to grow and really successful at germinating. What you really want to do is just soak the growing medium. So if it's hemp or newspaper, you want to put in like a baking dish or an old plate or something like that, just something that can hold a little bit of water, generally like a centimeter or so, and just enough so you can get it all moist. So you want to soak it through, drain it. You don't want to be growing these seeds underwater, obviously. So you just want to prepare a surface where you have the growing medium, it's nice and moist, and that will then provide the perfect environment for the seeds to grow. The next step is just sprinkle the microgreens on top. So there's no real fancy technique to this. I usually just get a cup and some seeds and just sort of sprinkle them out like that. I've chosen the example of hundreds and thousands on some fairy bread because that's kind of the density that you're looking for. So you want them to be fairly close together because you want a good sort of lush crop once it starts to germinate, but you don't want them like really on top of each other because they'll have issues germinating and you'll have issues with airflow as well. So just sprinkle them sort of reasonably densely, and then make sure they're sort of all contacting the growing medium, so be it hemp or paper or the soil, and they can just go right on top. So you're not having to really plant these like you would sort of a normal seed if you're trying to raise a seedling. So it's really easy. It's easy for kids to do. They can just sprinkle it on top as well. So it's not very technical at all. After that, you just need to wet the microgreens. So the seeds need to be really moist and maintain that moisture for germination. So we just use a spray bottle and just go over the top and give it a really good spritz, probably more than you think you need to. And that way the seeds will all be wet, the growing medium's wet. So you've got this perfect sort of moist environment for the seeds to kick off germination. And then you just need to cover them, and covering them obviously imitates the seed being underground, so under the soil. So lots of things you can use. You can use a lid of an old Tupperware container. You can use another tray or a plate or anything to go on top, just as long as you've covered sort of the majority of the growing area. And that's pretty much it. So the most microgreens, 10 to 14 days is the general sort of germination time, which is really great. So really in 2 weeks, you can have fresh produce ready to eat. Some are a bit faster, some are a bit slower. And during that growing process, all you want to do is sort of lift the lid up every day or two and just give it a bit of a spray. And that way you'll keep everything nice and moist. That also allows a bit of fresh air in there because airflow is important. And you'll know that the microgreens are ready because they'll start to sort of bulk up, as you can see in the picture there. It looks really lush and really healthy, and that's sort of the sign that it's good to go. And you just snip it off. There's a photo just back here, sort of just above the base. You don't want to pull the microgreen out because you don't want to pull the roots with it. They're not really that tasty. So you just want to snip off the microgreen, generally like sort of 2 to 3 centimeters from the base. And then you can sprinkle it on your food. The bigger microgreens like radish and snow peas are great in a salad, you know, as a base for a salad of themselves. And the other ones are good as sort of garnishes or, you know, put into smoothies as well. They go really good in green smoothies, and it's a great way to get some really good like dense nutrition into meals. And that's another really important part of microgreens is with all seeds, all the energy is in the seed at the time of germination for it to get to that sort of next stage of growth, for it to then support itself with its own root system and photosynthesis and things like that. So microgreens are actually really nutritionally dense. It's like a little kind of meal starter kit in one. So adding them to your meals is a good way to add like a lot of nutrition with not a lot of sort of volume. So it's a really good way to supplement your nutrition at home. Yeah, that's sort of a big part of what we're doing at Farmwall. We're starting to get out into schools as well, and we're really encouraging workplaces to get on board. We're just finding it's a really great way for people to connect. So we love that people finding that have green thumbs after all. You don't need a lot of setup. You don't have to be on acreage to, you know, grow, you know, big vegetable patches. You can do this literally on a kitchen bench or in your laundry, in a school classroom, on an office sort of environment. There's lots of places you can do this. So that's sort of, yeah, the 101 of growing microgreens. As for the seeds, you get them from sort of any general garden store. We recommend sort of supporting your local sort of nursery. Also, plenty of great places online in Australia that will ship you seeds as well. So that's kind of the presentation. I guess we can throw it to some Q&A with Gert and myself and go from there.
Yes, thanks, Farmer Luke. That was excellent. It's so good you can do it anywhere. We have a few questions, so and anyone else, please feel free to drop your questions in. Felicity would like to know what's the range of ideal temperatures for growing microgreens, and can you do it outside or is it best inside?
Definitely generally inside. You're looking, you don't really want it to go above sort of 23, 24 degrees. Above that, you'll start to have some issues with germination and then also mold growth, and the leaves won't be very strong. So generally indoors, that temperature is going to be fairly easy to maintain, unless you are in sort of more extreme climates or in Australian summer, or maybe down in, you know, Tasmania in the winter. But generally inside your home is going to be in that kind of nice, comfortable range. So that's sort of what we recommend. Yeah, so not really for growing outside.
Good. No, I'd like to know what happens if you don't harvest and they keep growing.
So yeah, they'll keep growing, but at that density that they're seeded, we're going to start to crowd each other out. So they're not really going to become the future plant that you want it to be. Some of them, like Mizuna, can get to what we call the second stage leaf growth, which is what we call the true leaf. So it looks like the plant would look like in the wild if you were trying to cultivate it and harvest it as a fully sized plant. But something like broccoli, for example, there might be 100 broccoli seeds germinating within something the size of a piece of A4 paper. A broccoli plant generally needs sort of 1 to 2 meters by itself to grow. So you can just imagine that many plants together, it's not going to happen. So you need to be harvesting them at that sort of 14-day mark to get the most out of them.
Carolina would like to know if you need special lights. But
yeah, we use a full spectrum LED, which basically offers, it's like a white light and offers all of the color spectrum within that light. If you want to get really technical, you can experiment with different sort of color and wavelengths within that light spectrum. So red or more blue or more green, and that can influence different microgreens at different stages of their growth. It can promote different sort of characteristics to their growth. So one might bring a crispier leaf, one might bring a bigger leaf. This is starting to get a bit more technical though. So for the average sort of home user, just a standard LED grow light is all that you need. And our plants do really well under those.
Okay, great. And
one from Jim in the general chat here about
yes,
what
yeah.
microgreens high in iron. Generally, dark green leafy vegetables are the ones that are high in iron. So for us, that's broccoli, rocket, even radish as well. So anything that's dark green and leafy, just in general in the vegetable world, are the really highest iron sources.
Good. I have a question about sourcing seeds. Obviously, you need a good quantity of seeds. Normal seed packets from garden shops have fairly small quantities. And how and where you could perhaps make sure you source organic seeds.
Yeah, G does a lot of the seed ordering and has quite a few places we get them from.
Mm-hmm.
Yeah, it's most important that they're natural. I found. So if you order seeds from large suppliers, they're often treated, especially the ones for agriculture. So you end up with like a fluorescent green seeds in a bag. So you definitely want to avoid those, and because you don't want those pesticides in your greens. Yeah, but there's a range of good organic suppliers. Like most of our seeds on our website are definitely natural, so untreated. And then there's a range of different organic seed suppliers, which you've got, of course, pay a premium for, but I don't think it's necessary other than having a real natural seed. Yeah.
Okay, Pam would like to know, after harvest, what do you do with the leftovers? I assume you can compost them.
Yeah, absolutely. So one important thing, and part of it sort of being a circular system, is that all the growing materials are compostable. So once you've harvested, you're basically left with your growing medium, whichever you chose, and root matter. So that all can go straight into your green waste, to your worm farm, to your compost system. The hemp that we use is fully compostable. So we just generally put that into the green waste bins that we have on site. So that's a good thing. There's no sort of landfill or any waste associated with it. So that's a really good thing to do with. And at home, you can put it in your compost bin as well.
Okay. You may have covered this, but I guess to just go over it again, Barbara would like to know, after you trim them, do they grow leaves again?
Pretty much no, because really what you're doing when you're harvesting is you're cutting the top of the plant off. So there's nothing left for it to grow from. So you're effectively killing it. Sometimes you will get some second growth if the roots are well enough established and there's enough light to get in there and to kick off another leaf. Or sometimes you might not harvest the complete tray. And so there are some microgreens that have stayed alive. But generally, once you've harvested it, you won't get any more growth. So you really want to wait till sort of they all reach a good level and then sort of do the whole tray.
And it's one question from Marissa, who's going to know if this is something you could set up in a classroom, I guess,
yeah,
for the
absolutely.
younger generation.
Yeah. That's something we're focusing on a lot. So we have a sort of a mini Farmwall kit. You can see in the slide here on the right. That's a small acquaponics system. So we've got fish at the bottom. The fish create waste that feeds into the plants, and the plants utilize that waste and turn it into nitrogen, and then they filter the water for us before it goes back down to the fish. So that's a very simple aquaponic system, and that's a kit that works very, very well in classrooms. And we have online things that instruct people on how to use that as well. So definitely, classrooms it's really great for kids. Early secondary. It's really easy for them to follow along.
Okay.
Basil there, how many harvests? Yeah, just one harvest basically. So once you've harvested the microgreens, that's it. You'll need to throw out the root matter and reseed and do the germination process all over again.
Okay, well, thanks, Luke and Gert. That's brought us to the end of the questions. And also, I'd like to thank Nick as well. It's been very informative. And it's so important now that we all have the knowledge to be able to grow our own food and keep ourselves healthy. So just before we go, I'd just like to let everyone know about an event coming up, which is a big event for Renew. It's Sustainable House Day, which happens every year. This year it'll be occurring on the 17th of October. But prior to that, there will be a month of online webinars and hopefully some in-person events with partner organisations, obviously subject to COVID restrictions. If you go to sustainablehouseday.com to find out more, but you will find a lot of access to a lot of houses that have been built sustainably, and a lot of them include permaculture gardens. And so you'll be able to learn more about the techniques we've been talking about tonight. So thank you, everyone. And thanks again to our speakers for providing such a great presentation.